So this session largely would be looking at, because we had been hearing since yesterday on autonomous, mostly vehicle you talked about, but autonomous, if you look at, there are various different applications, home applications, there's autonomous things which goes on factories, that something goes on air in terms of drones basically, right? So, and until now, the most of the security discipline that we learn is largely the IT system which is connected to the network, laptops and machines, and now mobile basically, right? So we like to dwell into how these autonomous systems which are into physical environment and how they are getting built basically, and how the security and privacy, which you just heard in last session as well, can work here basically. How it is different than typical IT security that we talk about or cybersecurity we talk about. And to cover that topic, we have Rostow, which has a very long critical industry experience, and Mansi, which is coming from the manufacturing sector here basically. I'd like to start with Mansi, right? So we know security and IT is very well. So when you are managing security for Apollo Tyres, what it means to manage security for a manufacturing company?
Yeah, thank you, and hi, good afternoon, everyone. So sessions after lunch is always really this thing. So one thing to wake you all up, one question to all of you, like, what does brakes do to a car? So I think, anybody? Okay, so basically it helps you stop, right?
Yeah.
But what I say is that it gives you speed, because at the back of the mind, you know the brakes are with you. That is what, security is for an autonomous, what we're talking about. Like, if you know that all those tools and everything has been implemented, then only, you can drive that change. What you want to do is using AI, ML, or using, different types of technologies. So coming back to Vinayak's question, that, what it means for us, it is not only IT, but IT, OT convergence. Because Apollo being a large tire manufacturing company, we have a lot of automated robots. We have a lot of, legacy OT systems, which are already there, highly connected factories, and all running on IoT and stuff like that. So for us, one is how to manage this entire security perimeter. So what we do there is that, where is the visibility for OT? Where is the visibility for all these robots which are there? So can I depend on the OEM for the security, or can I have a transparent system which I can build in? That is one question which we really work on. Second is that where OT is concerned, the CIA, which is our core for IT security, confidentiality, integrity, and availability, changes completely. Now in manufacturing setup, it is all about availability. My robots can't go down. Even when you are managing IT security, okay, you lose data. It is also very big, but if a plant goes down, it's a huge financial loss, so huge brand loss. There are different suppliers, different customers which are linked to us. So that is what we need to manage. And third is, you all know that manufacturing people are not so tech savvy. So cyber user awareness is something which we really struggle with. So these are the three aspects which we really work on where manufacturing is concerned.
So Rostow, after long working and leading a big IT industry, so it's inspiration for us that you are working in cybersecurity. And now we know the kind of volume and velocity and complexity that challenges we have. And in IT at least, we are trying to achieve a lot of things through automation, right? Automation of security and automation of those controls are becoming so important. But when it comes to physical environment, so can something be achieved that we are achieved in a SaaS environment or IT environment?
I definitely think we can, but maybe I'll just take Mansi's example of the brake and take it in a different direction from where she took it. Not only, and link it back to the session that we have today, which is both connected and autonomous. So not only do you have a brake which the driver can use if he needs to change the speed of the car or bring the car to a halt based on road conditions, you also have connected and autonomous brakes now, right? Many cars today, currently it's in the high-end cars, but typically these things will move into other cars as well over time. So the car measures its speed, it measures the speed between it and whatever another vehicle or whatever in front, and if it feels that you're going too fast and you can't brake, first it gives you like a red light on the dashboard saying that, or like a beep or whatever to warn you, and if you still don't pay attention in your driving, you just tap the brake for a second so that maybe you are distracted or whatever, so it helps you get there. So not only did you have a brake that helps you control the speed, but you also have a connected and at least partially autonomous brake, which brings the driver's focus back to safety, security, etc. There. So that's the essence of what is happening today. You have a combination of systems which historically only depended on the human input, the human judgment, the human analysis, etc. there. And we have seen that there are many times that judgment, that analysis does not live up to the expectations, or is unable to deliver based on the ground reality. And therefore, autonomous systems are now supplementing the human at some stage there. So if you go into any sort of physical environment which is highly automated and highly connected, factories are one example, but I'll give you another example. Many large trading firms in New York City, for example, all use algorithmic trading. They get a whole range of information from news sources and company annual reports and all the kind of stuff there, and automatically decide whether to buy a stock or sell a stock. So it's as an autonomous and a connected system as you can get in a car and a factory. There it's a physical system. An actual trade gets placed for buy Tesla or sell Tesla of this quantity, etc. there. So this use of this technology is happening in physical systems across a whole range of environments, many of which are sort of difficult for us to even fathom right now. One hedge fund in the US, for example, has an AI algorithm as their board member. So that's the level with which these technologies are sort of progressing at the moment. But the issue in my mind is that in these kind of physical environments where so much of autonomous decisions and so much of connectivity has come in, there's probably two things that this audience and all of us in the sort of tech industry need to be mindful of. At one level, I think it's important to build in some intelligence to slow down systems where appropriate. Because what ends up happening in most of these systems is that you analyze whatever 100,000 events that have happened in the past, and you feed that into the system. The system then sees a new event, matches it with what it has been trained on, and then takes a decision for the future. But once in a while, you come across an event that has not happened in the past. And you can't allow a physical system to either crash or create some kind of harm to anybody, to itself or to somebody around them or to the environment or whatever there. So while we are designing such systems, where appropriate, we should figure out a way to go back to Mansi's example, put a brake on the system, invite an input from somebody who can then handle that and take an appropriate decision, etc. at one level. The second thing that collectively all of us in the tech industry need to keep in mind is that most of these systems are an integration of hardware and software, so integrated that the lines become very badly blurred. And therefore, for example, the kind of quality that needs to go into engineering, to software development, to testing and all of that there are an order of magnitude higher than what you've seen in traditional applications. I'm not trying to make fun of Microsoft or SAP or whatever. Those kind of application software operate at a level where a certain tolerance for quality exists in those kind of systems. But for example, a robot in Mansi's factory in Apollo can't have that same level of tolerance for quality. It has to answer to and adhere to a much higher sort of quality standards there. So therefore, for example, people who are in software testing, the amount of testing you need to do for performance, for security, and for many other factors is an order of magnitude, magnitude higher. Therefore, my sort of sense at the moment, based on whatever I have studied about this, is we need to broadly categorize these systems in three buckets. For example, if it was that stock trading kind of a connected and autonomous system, maybe the level of human input required can be slightly lesser, and the majority of the actions, decisions can be automated. Somewhere there could be other systems, for example, like a radiology receiving an input and analyzing it and giving feedback to the doctor. Maybe it's partial. But maybe there are other systems like a factory where the amount of human input into that ultimate process has to be higher, notwithstanding the benefits and the advantages of connected and autonomous systems, because the kind of issues if something goes wrong is higher there. So therefore, the necessity for human intervention depends on the seriousness or the sort of impact that system could have.
Yeah. So let's delve in some of those areas that Mansi you talked about, right? So things which is in physical environment, be it a car, be it a robot, be it any other autonomous vehicle basically, right? Or any things basically, right? So one is hardware, which is accessible, and until now we are not really used to look at hardware level security, right? And that's why IoT security, hardware security is now becoming more important element here because things are getting accessible to you basically. And this is a new discipline for us as a security professional. Second part is you talked about there's a legacy, right? And things in IT system is very easy to update, easy to do patching basically. So can you just dwell challenges in these two areas?
Yeah, sure. So basically in my company what happened is there is a lot of legacy system. So I said, okay, can we raise a capex and start, replacing them? So the question which came from the unit head is that, okay, I replace it now. What after 5 years? Again, you'll ask me to replace it. It's not like your IT system. There are lakhs and lakhs of rupees which go into just getting one robot updated. So that's a big concern from management, and which they are actually right. So for that, I think one thing which we really need to look at is, as I think Rostow also rightly said, security by design, and really put a lot of thought to it. That if you are buying a new machine, discuss with the OEM, because right now, earlier what used to happen was OEM was managing the entire security. It was like, I'm going to manage it, that's fine. But as we're talking about autonomous, we're saying that I want transparency. I want to implement my controls. I want to know what's happening in my, all that SCADA pipelines and what's happening. So that visibility is required. So whenever we are discussing a new kind of a, robot or any factory or any machine which is coming in, first we need to look at security by design. That is, which we have really, trying to educate our teams, so that we can implement the controls we want. Because mostly what happens, the challenge which we feel is that we have bought a machine, and it's a new machine, they're saying it's all upgraded, everything is new, but if I want to implement a new antivirus, which is only for OT security, they say it can't be implemented because it's not proprietary. So that openness is something which we are really looking at. That is a big challenge. And second is that we can't replace it for 5 years. So maybe when we do security by design, not only software,
And once you have cryptography implemented, and suddenly we will get into the age of quantum computing, which probably algorithm that you are implementing could get compromised in coming years. Suppose crypto supremacy comes in picture actually. So how do you, so system design, security by design is you will actually going in terms of how you are implementing hardware, how you implementing cryptography. It's not actually only the application level changes. So anything that you would like to dwell, Rostow, on this, how things will change from now in terms of quantum computing coming in and how that will impact in this area?
I think there's so much that we don't know about this whole field right now, just literally exploding at the moment, right? With so much of money coming in, so much of effort coming in, so much of work being done at academic institutions like say IIT Madras and others on this whole area there. So I think we only know some 0.1% of the overall picture right now, which in my mind, I think there's a little bit of a worry, or maybe I'll even go so boldly as to call it a little bit of a fear, because it can potentially take us in all kinds of wrong directions as well, this thing. But before I continue a little bit more on your question, Vinayak, I just want to go to Mansi's comment with a different aspect of that as well. In addition to all the thoughts that have already been shared, I think the manufacturing industry also has an additional requirement / constraint, which is cost. Other industries, for example, the ability to spend money for technology upgrade. For example, if you're a bank or if you're some other industries there, the nature of that industry, the pricing power, the profit margins, etc. in that industry allow you to spend a little bit more, or maybe whatever, because you make more money, you can also then have refresh cycles, you can have investment appetite, etc. higher there. Whereas manufacturing, first of all, typically manufacturing margins are much lower than services or other industries at one level. Secondly, manufacturing industry, from the time you decide to put a plant together, put that plant and start seeing revenues also takes much longer in terms of gestation period, implementation, etc. there. So the fact that your revenues come much later means then the cost of the input has to be much smaller there. And maybe our industry needs to do a lot more, especially the cybersecurity industry, but also broadly the technology industry as well, this thing. How do we figure out systems that are more efficient, more reliable, longer lasting, etc., but also more cost effective? And especially with manufacturing moving to the largely Asian context. China was the biggest manufacturing hub for a long time, but even Vietnam, Malaysia, India that are coming up, all don't have the affordability that Western kind of manufacturing companies, plants, etc. have. So I think a lot more needs to be done on making these systems more cost effective as well. But coming back to Vinayak's question on quantum, I think the opportunities first, I would say, are enormous. For example, I don't know how many of you tracked one of the most intractable problems in human biology was how do proteins interact to create energy, to create action, to fight a disease, to cause a disease, etc. And Google now has a computer that can called AlphaFold, which can predict how proteins fold there. And therefore, for example, the opportunities that this has for understanding the physical system, understanding the human body as a physical system. You know, why does something happen? Why do I have less hair than Vinayak? So many things so many aspects of the human body can get unlocked now because we now have the ability to understand processes within the body through technology there. Another great example is if you were to look at weather patterns, there is so much of data that you need to analyze to be able to predict whether it's going to rain tomorrow or not. And so much depends on it. Therefore, for example, newer technology fields like quantum can make a huge impact to areas that we just haven't been able to solve historically, simply because we didn't have the compute power available to be able to take all of those kind of really large complex problems and solve them within a meaningful time frame there. But that much of power, while it can be useful for so many good things, like I said, for preventing disease, for doing gene editing, or for making human life more accomplished, more successful in many ways, can also create complications. The most important thing that almost everybody, starting from the NIST proclamations a few years back, the US government initiative on quantum computing, etc., the most important immediate implication for us is that as more quantum computers become available online, the easiest thing to break is the encryption that is currently part of all systems. So typically 256 kbps, 512 kbps is by and far the most common encryption standards that RSA implemented. So if for example, I'm an ICICI Bank customer, I go to icicibank.com, it's an HTTPS enabled website, which is either a 256 or a 512 KB encryption. A quantum computer can break it typically, I would say today, within a few hours. Over time, when that becomes more larger, it can break that more easily. Military grade, government, intelligence, etc., typically operate at maybe 1028 kind of encryption. That may also start getting broken. So not only do commercial secrets, commercial transactions all become, vulnerable immediately, but even state secrets, even diplomacy, even military secrets become vulnerable sooner. So I think the immediate implication by the unleashing of quantum power is how do you protect your systems for encryption against the traditional kind of encryption methods.
Yeah, and on this one important part is we are doing this study and we are realizing that IT will be still easy because it's very easy for you to change those algorithms, but it will be very difficult for autonomous system to really change the new algorithms which can withstand with the quantum computing. But Mansi, one thing which Rostow talked about, technology industry, transaction processing industry like banking industry, the operating margins are definitely significantly higher, whereas the manufacturing company margins are critical, right? In that case, how you, briefly you can talk about, and then I'll come to privacy, because that's one of the important areas that we'll cover. So how do you create a kind of a business case to get your management invest in security?
Yeah, so I think that's a very good point, and I have talked about this a lot of times. So basically, the table have changed. Yeah. Earlier we used to run after management. Yeah. Now management understands the importance of security. So I would say budgets is not so much of a problem now.
Okay.
Yeah, cybersecurity budgets have really increased. But yes, at the same time, you need to give them priority.
Yeah.
Because, let them take the decision. So what we have done is, it's not my decision alone. We have created an InfoSec committee. So in that InfoSec committee, we have a board member, we have a plant people, we have, IT experts, and then we take and we have CFO, and we take a sound decision that yes, these are the risks which we foresee, and this is the cost to mitigate that risk. So where does the business feel is the right? So it has to gel with the business. Otherwise, then you can implement 100 controls, but if at the end of the day, the business doesn't function, that's not a requirement.
Sorry, I just want to add another point to Mansi's comment,
Yeah.
and I realize this is the third or the fourth time that I'm doing this today. But I think going back to a point, Mansi, that you made in the beginning, that how do you keep security in mind while you design things? For example, in the initial wave, IoT is at least like a 10-year-old phenomenon, right? So in the initial waves when IoT came, everybody made rara about Industry 4.0, and lots of good things happened as a result of that, and I can't take away the credit. But for example, we didn't keep in mind that most of these sensors that you deploy are so small, physically small, which means the compute on it is really small. Practically, there's no battery on it. And therefore, for example, the code that was written, let's assume in a simplistic sense, it's monitoring temperature somewhere. That sensor has no ability to have any security on it at all, right? So it is there on some machine or whatever. It is pushing that temperature reading into some gateway, and that gateway is pushing into some cloud center or whatever there. In that entire chain, because of the way it was set up, security was an afterthought. And now, for example, you can just pump 100 million events through that chain, which will just overwhelm that system and therefore break down that whole aspect of connected and autonomous processes there, which is why when we are at least now with the realization that we've had, can security be as, what shall I say, critical in the design of OT? Beyond the jazziness of it, beyond the performance of it, beyond the functionality of it, I think we need to keep security in mind while designing it as well there, which is probably one of the reasons why IoT hasn't taken off to its true potential. If you go back to 2015, for example, and read all the IoT industry reports from Gartner or Microsoft or whatever, they all predicted such a rosy picture, but they haven't taken off to that extent. It's because, for example, all the angles were not considered. And I think today, with the benefit of that learning, when we come up with newer systems, ideas and newer technology, etc., we need to keep in mind that threat actors are real, technology risks are real, cybersecurity issues are real, and therefore, how do we keep keep some of these things in mind while designing newer technologies?
Yeah, and then that's what the challenge with autonomous system is. The environment is so constrained, right, from form factor to processing power available to battery that you have. So designing security in a constrained environment is a big challenge, big research and innovation challenge. And nowadays I'm seeing a lot of research and innovations coming in this area. So we have some time, so let's spend some time on privacy, because we know that transaction processing industry definitely are worried about it. But how much in this industry 4.0 and automation that you look at, how much things, now we have Data Protection Act, DPDP Act is also, how much privacy will influence the way the things are being laid down and looked at?
Yeah, so I really feel that privacy, I'm very glad, by the way, that the act is coming for all of us as Indian citizens. But so basically, like, let's take an example. Earlier, as I said, the security was embedded in the OEM product, and we did not have any right to view what they're doing. Let's take a simple example of a camera, not even drone. Earlier, we came to know that maybe this camera is talking back to some other third country. Now, this is privacy data. There was no law which was supporting us there, and it was very controlled environment which we couldn't see. So that's why I think now with the law coming in, and now we asking them that, how the hardware is designed. I think software is still okay. We can, understand a lot of things. But for me, I think the OEM part, there, like he also mentioned, that in this entire ecosystem, how are hardware getting secured, and do we have an access to view what's happening there, is something where the privacy
you
part
have
will play
handle now to push OEM hard on this side.
That's true.
Yeah, okay. So privacy, when we talk about in this ecosystem, and more important security as well. So this challenge of this segment is mostly, this market is OEM driven market, and there is a user and OEM. Whereas in IT, we have entire third-party products and solution company like yours had been working, whereas they're still OEM-driven. protocol are still very much kind of proprietary basically. They're not open in nature basically. So that needs to be broken in terms of making the security really work there.
Even the management of these systems in our factories have been done by OEM only,
Yeah.
because
So that's what-
there's a skill gap as
Yeah,
well.
yeah,
You know,
yeah.
people don't understand
Yeah.
this, how it works.
I think the implications of these are just so huge, but on a lighter vein, but also as a matter of pride, I think in the Digital Privacy Act, the gender used is always she. So the fact that it also is a reflection of not just individuals and societies, etc., but even regulators now becoming a little bit more inclusive. Otherwise, if you go look at all the previous acts in the past, it always said, he shall do this, he shan't do this kind of stuff there. So for the first time, the language refers to a gender, the female gender in the act there. So I think it's a great matter of pride for all of us in the act. But I think from a process and a technology point of view, I think we need to figure out a way by which is a perennial problem that industries in the West have had, because Europe had GDPR in the past, all the California industries have had CCPA for a while now, right? So therefore we have the benefit of what some of those jurisdictions have gone through from a privacy angle. And I think the biggest learning for those companies in those jurisdictions is that they frankly have no clue what data they have. Because they're just collecting so much data, right? Like, let's assume you're a hotel company. How many people come on your website? What IP address they come from? To if you're a Tesla, who is driving? You know the person. You know their house address. You know so many things about the users of your systems that nobody in many of these large enterprises even understand what data that they have, which is one issue. So an inventory of all the data that you have is the first problem. Secondly, classifying. So just to use that example of Tesla, 500,000 vehicles, I believe, or 5 million vehicles, or whatever the previous speaker said, are used. All the data from all those users are coming back to Tesla right now. How do you classify that? There are some pieces of data there could be low value, some could be very high value. The level of protection required for that is very different there. So therefore, classifying the data and then deciding what needs protection, protected appropriately, what is not that protected. Maybe you can use it with the thing there. Lastly, to Vinayak's point, many of these companies are not using the data themselves, right? So they are sharing it with somebody who's part of their ecosystem, some vendor, for either to show a personalized ad for you or whatever else there. Appropriate governance over what data you share with who, for what use cases, I think is another thing. Because in the absence of all of that, a simple line in the law that says right to forget. The government can pass a law saying that I, as a consumer, tomorrow morning I go to HDFC Bank or ICICI Bank and say right to forget me. But HDFC Bank or ICICI Bank in this example can't implement it if they don't know what data they have of me and where it's stored, etc. I think it's an enormous amount of challenges that businesses will have to face today.
So I know time is up, and I know 30 minutes is a very short time to cover security and privacy, but hope we are able to unveil at least some part of the discussion that we wanted to have it here. Basically, some level of understanding we could able to bring together. So for that, please join me to give big hand to my panelists here. I'm sorry I'm not able to take the questions.
And I guess Mansi and I could do whatever we could because of Vinayak having right, pointed, thought-provoking questions. So thank you, Vinayak, as well.
Yeah, we are really privileged to have you as a moderator. Thank you.
Thank you.
For more content on tech and leadership, subscribe to nasscom YouTube channel and press the bell icon to never miss an update.